Part 1. The Cybernetic Vision. Introduction. When we go to the movies or watch a video, we are willingly taking the role of a prisoner in Plato's cave. In Plato's famous allegory, a group of prisoners are tied and cannot turn their heads. Hidden from view in a balcony behind them are a group of artists who are using the light of a fire to project a series of shadows on the wall. The shadows the prisoners can see are the sole source of their experience. When one of them is set free, he is blinded by the sun's light. Plato's cave illustrates the limitations of having only one system to interpret the world. Traditional science, religions, and systems of government are systems to acquire and share knowledge, and each one is therefore a different version of Plato's cave. Each system imposes its own rules on how to see reality, and they generate conflict when their prisoners meet each other. Watching Universo Kubernetes is to walk into the world of cybernetics and chaos theory. The advantage of this language is that it allows us to connect the different caves and to build a reality that can be shared by everyone. The universe is like a huge cave, but it has no exit. This is our ultimate reality, imposing, imperturbable, and disquieting. It took humans thousands of years to discover the regularity of the movement of the stars. Since then, the universe has influenced the idea of God, of the world, and of man. However, the universe described by the Greeks is different from the universe of the Middle Ages, the one of the Industrial Revolution, and the one held during the Atomic Era. In the information age, we are witnessing a new and surprising universe. This new vision is full of implications for each and every human being, the most important being the possibility of putting an end to the historic rivalries between religions and among religion, science, and government. We shall go deeper into this new and modern scientific vision of the universe, of the world, and of man. We start by traveling back in time briefly to the 14th century to visit England and take note of the phrase of William of Ockham, which says, "Plurality should not be postulated without necessity." This methodological principle is known as Occam's razor and is applied in science when there are two complete explanations for a given observed phenomena. In this case, the simplest explanation is preferable. Occam's razor has helped science go forward as ordered and trustworthy knowledge. I shall give now an example of this principle at work. In ancient Greece, Ptolemy studied the movement of the sun and the planets and made a detailed explanation. He showed just how the sun and the planets revolved around the earth. This view of the universe prevailed during 13 centuries until the Middle Ages, when Copernicus exposed an explanation that turned out to be a better and simpler one. Ptolemy's geocentric universe faced the exact same challenge as any other scientific explanation or theory: its prediction capability. I will show you what I mean. This animation shows the location of Mars in the night sky on Earth exactly at midnight every night from October 13th, 1996 to July 26th, 1997. Please notice the path that Mars follows. Midway through its journey, it traces a strange, flattened loop. In modern terms, we can say that Ptolemy created a mechanical model of the universe. This model shows the Earth in the center with the Sun revolving around the Earth, and Mars revolving around both the Sun and the Earth. This model is capable of making predictions, but according to Occam's razor, scientifically less useful because it is more complicated than the model proposed by Copernicus centuries later. In contrast to geocentrism, Copernicus's graphic explanation of 1543 placed the Sun as the center of the orbits of the planets, although the stars remained fixed to gigantic celestial and invisible spheres. This latter explanation, the heliocentric universe, is far more simple and allows much better and easier predictions. Ptolemy and Copernicus were looking at basically the same reality, the same sun, the same planets, the same stars. What was different was the map that each of these scientists had built inside his head. They had a very different model of reality. Thanks to modern technology, everybody is the center of the universe. I have in my hand my iPhone that allows me to connect to the internet and access databases which give me the positions of the constellations of stars regardless of my location. I can travel to the past or to the future and visit Greece 2000 years ago at a time when Ptolemy was busy building his model of the geocentric universe. I am holding in my hands a perfect model of the universe. Welcome. My name is Javierlivas. Thank you for making this journey with me through the history of cybernetics, its concepts, and the benefits it has brought to the world we live in. Some 4 centuries ago, Blaise Pascal, the famous French philosopher, mathematician, and physicist, was fond of saying that knowledge is like a sphere. The more the sphere of knowledge grows, the bigger its contact with the unknown. Let's take this image and assume that the entire knowledge of the Greeks is described by the orange sphere. Back then, anything that could not be directly explained was attributed to the gods. We color that larger sphere gray. With the arrival of classical science, the sphere of knowledge grew in size. The laws of physics were attributed to one god, and this god was the great designer and assumed to be also the initial cause of everything in existence. In the past 100 years, however, quantum physics first, and more importantly, cybernetics later, have increased the sphere of knowledge a great deal more and have unraveled some of the mysteries that eluded classical science. Cybernetics has given man a new awareness of his natural gifts and capabilities. It has also helped to divulge the idea that information is power. In this day and age, nobody can help noticing that the world is quite complex, dynamical, and systemic. That being so, we must also ask, how is it that religious and government institutions are still trying to govern the world by using cause and effect methods? Maintaining a reductionist perspective of the economy, the law, or finance is contemplating the universe as a clockwork or made of billiard balls. The mechanical vision of the universe has very serious limitations when it comes to explaining the complexity that is everywhere. The new vision that we need has been in the making since 1948 with the birth of cybernetics and more recently with the appearance of chaos theory. A new language that is specialized in understanding complex systems has been building up ever since. It is truly a different way of making science, and it provides many answers to difficult questions that classical science has been unable to provide. This new scientific paradigm has generated the technology that has allowed the discovery of a universe that is not static, but rather expanding, and had a beginning. This video is dedicated to the scientists linked to cybernetics that have made it possible to find an important connection between science and religion and a new path towards spirituality. Stafford Beer, my dear friend and mentor, was always interested in the connections between science, philosophy, and religion. His ideas have a primary influence in the contents of this video, as they have also influenced many followers and disciples that have created the Metaphorum group after he died in 2002. In the first part, we look at cybernetics as a new scientific paradigm and show the contrast with the evolution of classical science. We give specific answers to what is cybernetics and why we need models and a special language to speak about complex systems in a surprising universe. In part 2, we examine the living vortices and artificial life in order to understand the implications of chaos theory and the miracle of life. Strange attractors, the concept of recursion, the viable system model, and identity are examined to this end. In part 3, we proceed to study the concept of purpose and emergence. With these new concepts on hand, we go on to provide the answers to the difficult questions regarding the existence of God, the universe, and man. Chapter 1: The Birth of a New Scientific Paradigm. New York City, March 8th and 9th, 1946. World War II has ended a few months back. A group of 21 of the world's leading scientists gather in this city for the first time to discuss something that has intrigued all of them: systems that have purposes and the underlying concept with a huge scientific potential: information feedback. This is the first of 10 famous meetings held by the Macy Foundation. These gatherings of scientists are now being called the Big Bang of the Information Age. The main characters in the beginning of this new science are Dr. Arturo Rosenbluth from Mexico, Dr. Norbert Wiener, the former child prodigy and mathematician from MIT, as well as Warren McCulloch, a neurophysiologist. The story goes that Dr. Rosenbluth organized monthly reunions at Vanderbilt Hall during his stay at Harvard University in the early 40s. It was during one of these events that he met Norbert Wiener. Later on, both of them got together with Julian Bigelow, produced a joint paper on teleological mechanisms, which are machines that pursue an objective. Another scientist who joined them later was Warren McCulloch, who had been studying logical circuits made up by neurons. He carried out his work with the help of a mathematical genius by the name of Walter Pitts. To get the meetings going after the war, the small group of hard scientists contacted the so-called soft scientist Margaret Mead and her husband Gregory Bateson. Dr. Frank Fremont Smith also joined the group and coordinated the activities on behalf of the Macy Foundation, the sponsor of the meetings. Another very distinguished participant was John von Neumann, an extremely brilliant mathematician born in Budapest, Hungary. It was von Neumann who addressed the Macy Foundation first reunion with the subject on the design of the electronic computer and compared it to the human brain. Von Neumann and Alan Turing, a mathematician and logician from England, share the merit of having invented the electronic computer with a programmable memory. Years back, Alan Turing had taken a first huge step when he invented the concept of the universal machine. Using these background ideas, von Neumann designed the logical scheme of the electronic computers still in use today. Ross Ashby, the British cybernetician, and Heinz von Forster, an Austrian biophysicist, also have made very important contributions to the new vision of the universe that we explore here. They were present at subsequent Macy Foundation meetings. Von Forster was put in charge of editing the memoirs of the meetings and years later generated key ideas about observer systems. C. West Churchman, Russell Ackoff, and Stafford Beer distinguished themselves in the early stages of operations research, that is, the application of mathematical methods in solving management problems. Churchman and Ackoff produced studies in philosophy and contributed many ideas to systemic thinking. Ross Ashby and Stafford Beer, in turn, applied control theory to biological and human organizations respectively, as we shall see further on. Information feedback is a concept that explains how control is achieved in automatic machinery, animals, and organizations of all types. Here is a typical feedback system. Feedback systems can be described as starting with a black box that has an input and an output. A comparator measures the output and compares it with the desired goal and sends an error signal to the input. As this error information arrives at the input, it generates the necessary response in the output to correct the error signal. This phenomena is called circular causality. Negative feedback is meant to control. Positive feedback means the same loop, producing the acceleration of the output. In this short video, Stafford Beer shows that information feedback is an inherent design feature and cannot be imposed from outside. To the right is a picture of James Watt, inventor of the Watt governor.
The important thing to realize about systems is how they are controlled. And we must get rid of any notion straight away that control is something imposed on the system from outside. It has to be built into it. Now you saw me operate this governor just now and noticed how the engine slowed down. Let's see how the mechanism works. Suppose the engine is racing. Then the governor flies open like that. You see it lifting here, transmitting the message along here, lifting that cam up here, and then shutting off a valve there. That is built into the system. It's called feedback, and feedback is ubiquitous in control system.
The Industrial Revolution, the growth of cities, the expansion of scientific and technological knowledge in the 19th century were propelled by the Watt governor, a cybernetic mechanism that preceded by far the science of control that would be invented centuries later. There was a total of 10 Macy Foundation meetings between the years of 1946 and 1953. One of the stellar moments happened in the first meeting when von Neumann gave his description of the modern electronic computer with a programmable memory and showed a diagram of its architecture for the very first time. Also during this first meeting, Rosenbluth and Wiener explained the bulk of the new concepts on feedback, messages, and information as part of the theory of communication. In the second meeting, which took place on September of 1946, Norbert Wiener defined information as negative entropy, using its exact same formula, but with a negative sign. Information is order. Entropy is a statistical measure of the opposite, disorder. By using this formula, the amount of information in a message becomes a measurable quantity. Wiener, then and there, chose the bit for binary digit as the basic unit of information. We can therefore say that the information age was born at that very moment. Here is a photograph of the attendees to the last meeting of the Cybernetics group in April 22nd, 24 in the year 1953, the only one held in Princeton, New Jersey. Cybernetics was created in reply to the scientific cooperation efforts made for war. 60 years ago, there were no hydrogen bombs, no atomic submarines, or intercontinental missiles, but we also did not have microwave ovens, digital watches, pocket calculators, small radios, or rechargeable batteries. There was no Teflon or antibiotics, transplants, and the DNA architecture was a mystery. The list can go on to include plastics and thousands of new materials. We did not have ATM machines, remote-controlled airplanes, cable television, or satellites. There were no computers or faxes, copiers, lasers, video recorders, compact discs, or DVDs. No internet, email, or YouTube, or cell phones. No Hubble telescope, space antennas, or trips to the moon. It is now very difficult to imagine a world without all these technological breakthroughs. Cybernetics has changed the world completely. It has also changed the way we see it, although many people still ignore how everything got started. We must now explore some other consequences in the area of politics, law, religion, and spiritual development. Chapter 2: The Big Questions. Recently acquired knowledge and the new methods available to get it enable us to return and ask the age-old questions regarding the existence of the universe, God, and man, and take another look at the ethical implications of our newly discovered gifts and capabilities. Instead of trying to provide answers based on superstitions or religious dogmas, history records an effort to appeal to philosophy and traditional science. But even classical science and philosophy are far away from what the new cybernetic and complex systems paradigm has to offer. The questions that men have been trying to answer in the past have been the following: who and what is man? What is our purpose? Is there an ultimate essence of things? Who created the universe? Does God exist? And can I trust my knowledge? Of course, nobody can answer questions without searching for the answers. When Galileo put together his first telescope, not many people became interested in taking a closer look at the cosmos. Most people thought they knew more than enough already. The world still seems to be divided between those who want to know and the many who really do not care. Can science and religion be reconciled? Both have held very different views of the universe. Galileo was sent to trial because the church did not approve that he sustained that the earth orbiting the sun was a scientific fact. So what does the Bible say about the creation of the universe? In the beginning there was chaos, and before chaos, nothing. The history of the creation of the universe, as described by the Bible, had no meaning for scientists for a long time. Aristotle, as well as Galileo and other scientists that came later, such as Newton and Einstein, believed the universe was static. Newton and his laws of physics described a mechanical and predictable solar system. Einstein later recognized having made the blunder of his life. It happened when he added a cosmological constant to his theory of relativity in order to compensate for a static universe. His relativity theory went hand in hand with the idea of an expanding universe, but he could just not accept the natural conclusion of his own theory. He later had no choice and admitted to his mistake. Scientists did not have the advantage of observing the universe through the Hubble Space Telescope until the last decade of the 20th century. Chapter 3: Maps, Models, and Languages. We have seen that Ptolemy and Copernicus described exactly the same reality in very different ways. Well, the fact is that every human being is constantly building and rebuilding the world inside his or her own head. Cybernetics recognizes that the brain is an intermediary between a human being and the external world around him. We are all building and rebuilding a model of the world for things that are important and things that are not as important too. The intermediation done by the brain means solving the problem of complexity. We attempt this by building models that are more or less useful. Unfortunately and inevitably, these models act as filters of that part of reality not included in the model. In order to see the same reality, people must share the same maps inside their heads. Mental maps serve just as signposts on a road. They are a useful reference. Without the proper concepts, the new reality can pass you by without being detected. People must get rid of the maps that the world of cause and effect has imposed on them. These old maps usually contain all types of prohibitions. Don't do this, don't do that, that is forbidden. The list is long. The same human being with two different mental maps acts in very different ways. He becomes two different persons. This table shows different logical levels of language, in accordance to the complexity each level implies. We start with the most simple language at the bottom. It is not by mere chance that these levels are directly related to the well-known academic levels. Children are taught to read words that describe objects such as tables and chairs, houses and apples. In the next level, they describe actions. Generalizations are next and logically superior. Above them appear cause and effect laws. We arrive at statistical truths and then go into the realm of cybernetics and complex systems. The transcendental systems are still higher and more difficult to understand, especially if you are not aware of the lower levels. The only merit ascribed to superstition is that it fills the gaps in knowledge generated by ignorance. Science has always been subjacent to our current worldview and provides support for our culture in general. However, every type of knowledge always acts as a filter that shapes our perception and forces its particular viewpoint on us. The filters that we adopt, however unconsciously, become part of our identity and our behavior. Chapter 4: The Evolution of Science. Let's make a very fast trip through the evolution of science, beginning with the Greeks, in order to get a sense of the filters that existed at the time and how they have changed throughout history. The prevailing Greek view considered a flat Earth as the center of the universe. The Greeks also believed that the world and everything in it was made just of four basic elements: earth, fire, air, and water. This map changed radically when the sun was seen as the center of the universe. Galileo, Kepler, Leibniz, and Newton contributed to describe the universe as a clockwork based on mechanical laws of cause and effect. The classical science paradigm got its main thrust from the first physics scientists in the 16th and 17th century. The universe is a mechanical entity and is subject to infallible mechanical laws. This worldview helps support royal families as the recipients of a divine will. The first chemists, based on experimental method, largely arrived in the 17th and 18th centuries. Science continued to redirect its interest to smaller and smaller objects, from physics to chemistry, and then in the 19th century it turned to study electricity and magnetism. In the meantime, biology was evolving slowly by erecting taxonomies. In the beginning of the 20th century, physics entered the atomic structure and started constructing theories on the nucleus, protons, neutrons, electrons. Many of them, such as Einstein, searched for an explanation that would show that everything was the result of particles moving about. However, Einstein and other great scientists of the time, such as Max Planck, Niels Bohr, and Werner Heisenberg, continued believing that they lived in a universe that was static, eternal, and infinite. A few years later, this vision became totally obsolete. First to appear was the realization that the sun was a star, one of hundreds of thousands that were part of the Milky Way galaxy. On January 1st, 1925, astronomers were informed in a paper written by Edwin Hubble that many other galaxies existed beyond the Milky Way. The map of the universe had changed radically. The coup de grace to the static universe came from the confirmation that galaxies are racing away from each other and are expanding the universe in all directions. In 1964, with the discovery of microwaves coming to us from space, the theory of the Big Bang took hold as the beginning of the universe. After a while, it became the most proven fact of all science. From this discovery onwards, science and the Bible are seen in close contact. The Bible had said, "There was a beginning." Science had been forced to reply, "A beginning, yes. A creator, we do not know." Chapter 5. What is Cybernetics? Plato and Aristotle mentioned the word Kubernetes in their work. Kubernetes is an important concept in the science of governance because it means the man at the helm. The Aristotelian definition of Kubernetes was lost for a long time. Whatever discoveries were made by Leibniz and his calculation machine in 1671, or by Charles Babbage in the year 1822 and his differential engine, or by George Boole's binary logic, they all came under the guise of mathematics. Cybernetics was not known in the role it now plays. In 1845, André-Marie Ampère, the French philosopher, resorted to the word cybernetic to designate the science of governing the state. A century after Ampère discovered the word, Norbert Wiener used it to christen the new science presented in his 1948 book called Cybernetics, or Control and Communications in the Animal and the Machine. Wiener showed for the first time in history that there was a way to connect two worlds that were considered completely different. Automatic machines, as well as animals, can display a behavior guided towards an end. Both use a feedback process to do so. During the 10 years that the Macy conferences lasted, mathematicians, philosophers, sociologists, psychologists, as well as doctors and other scientists collaborated to give cybernetics a sound foundation. Biology, physiology, sociology, and psychology begin applying the information feedback model, and by doing so create a revolution within their respective fields. As Heinz von Forster would later say, it seems that cybernetics was dissolved because so few people now look back. When Ross Ashby published his Introduction to Cybernetics, he gave it a much wider base than the one provided by Wiener. Ashby paved the way for the construction of a new scientific paradigm. Cybernetics grows and interprets the world according to new rules. Seen here are the theories, and to the left bottom are the disciplines that help create it. Nowadays, law, economics, and politics can be studied using the language of management cybernetics. If we look again to the map of the evolution of science, we can place the development of cybernetics according to the relevant contributions at the time they were made. We start with Plato and Aristotle, then the machines invented by Descartes, Pascal, and Leibniz. Babbage and Boole belong to the 19th century. In the middle of the 20th century, we find the important contributions of Alan Turing and the participants of the Macy conferences, followed by Ashby's book. Once we get to the Big Bang era, the next big contributors to cybernetics are Chertman, Akoff, von Forster, and Beer, as well as the researchers at the Santa Fe Institute in the mid-80s. The rapid ascent of cybernetics and of communications produces a world which is characterized by a rich web of interrelationships which cause a complexity explosion. Complexity becomes a theme that science begins to explore through the use of chaos theory. The world of information is a parallel world, just as vast as the physical world which it informs or gives form to. Here is a map showing a classification of systems which is useful for our purposes of exploring systems. Mechanical systems are predictable machines. Complex systems have such a large number of components or relationships among them that they are impossible to describe in detail. For this reason, we can only build models. Complex adaptive systems are comprised of many autonomous agents with their own survival strategies and can copy the successful strategies of other agents. Viable systems are those that have their own identity and stay alive because they are constantly rebuilding themselves using their capacity to learn and to adapt to changing circumstances. Cybernetics, as any other science, is interested in things that are repetitive. The difference with physics is clear. Cybernetics does not ask how something happened, but rather why it happened as it did and not something else. For instance, two embryos might look exactly the same to the naked eye, but one turns into a chimpanzee and the other into a human being. In both, the physical laws are the same, but cybernetics explains the different result. Cybernetics asks the following question: from this universe of possibilities, why this and not something else? While physics is interested in energy and matter exchanges, what is cybernetics interested in? Think about it. Control. 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 Information that controls energy. How does a small amount of energy become able to control a great amount of energy? The missing concept is amplification. Ross Ashby defined amplification as providing a quantity and producing another. Here are some examples of amplifiers in everyday life. We are now in a position to answer what cybernetics is. Actually, it is many things at the same time, given that it knows many things at the same time. Cybernetics is expert in control and communication, in computing and achieving results, expert in transformations, chaos, and self-organization, expert in complexity and change, in complex adaptive systems, expert in explaining why small differences can make big differences. It is the science of effective organization. The largest portion of the apple of knowledge. If we plot examples of systems according to their growing complexity in the x-axis and according to their randomness in the vertical y-axis, we get the following. Area 1 of organized simplicity that grows in complexity towards computers. Area 2 plots disorganized complexity, such as you find in gases and Brownian movements and can only be understood using statistics. Cybernetics is capable of explaining both automated machines plus all of Area 3 where businesses, the state, and the brain have their place in the graph. Cybernetics will take us to investigate the life of stars, to obtain the knowledge that we are searching for regarding the origins of the universe, the essence of man, and the existence of God. Together, we shall have to build a new map in your mind. Using the lens of cybernetics, you will be able to see the universe in a totally different way. Chapter 6: A Surprising Universe. Immanuel Kant, the philosopher from Vienna, once had these very famous words to say: "Two things awe me most, the starry sky above me and the moral law within me." All of cybernetics is built on the concept of difference. Here is a very important one. The distinction Kant makes between the stars and the moral law is a beautiful example of the distinction made earlier by French philosopher René Descartes. In 1637, Descartes set apart the laws of the body, material things, and the laws of the soul, spiritual things. By doing so, Descartes paved the way to the classical scientific method, later to be used by Newton to discover the first laws of physics. Cybernetics has allowed us to realize that the Cartesian divide is also exemplified by the difference between hardware and software, or simply between matter and information. The starry sky up above that Kant contemplates has to do with the very first of the quintessential questions. What are we? Where do we come from? What is our material endowment? What are we made of? On the other hand, Kant's admiration for the moral law within us has to do with a second great question. Who are we? This question is posed in relation to our spiritual endowment. Matter and spirit. There is no doubt that the Cartesian polarization is very relevant, as we shall see in greater detail later. As a combination of synergistic expression of both attributes, it will lead us to a third question. What is our purpose? Our double legacy, spiritual and material, gives us an infinite potential, but first, we need to know about it, and second, be willing to fulfill it. Cybernetics and chaos theory are needed to grasp the intricacies of our material nature. Stafford Beer, being an expert in cybernetics and a student of religion and philosophy, frequently alluded to Psalm 82 of the Bible to characterize the intimate essence of human beings. The final part of Psalm 82 says, "I have said, you are gods and children of the Most High, but you shall die like men and fall as one of the princes." The Bible says the same thing in another very famous and recognizable way. Man is created in God's image. What does this mean? What else can we say? What is behind all this? Let us find out what we can learn by looking at our material endowment. Let's find out why it is that cybernetics and the theories and models this new paradigm includes allows us to see the human being in a transcendental dimension. To do so, we must dig deeper into the material world first. From a material point of view, modern science and astrophysicists say that we humans are undoubtedly direct descendants of one of the 100 billion galaxies that travel majestically through space, mostly in the shape of gigantic vortices. Humans share the same order as the one being generated by these colossal vortices. Each living being on planet Earth reveals that same identical origin. The Bible says, "For dust you are, and to dust you will return." Modern science agrees that the Earth and everything in it, including all human beings, are built from the same stuff, star dust. The huge primordial star that died to inherit us, its heavy elements, must have been at least 8 times greater than the Sun. Only stars of this size can turn themselves into supernovas. Here we show the relative size of the Sun and other gigantic stars. The Sun looks like a small marble side by side with beach balls. When these gigantic bodies extinguish their energy reserves, they collapse and compress and explode with enormous force. The explosion of a supernova sends great quantities of dust clouds into space and emits light which is many times more intense than sunlight. From the ashes of a supernova, new suns such as ours are born. Here is an example in the M16 nebula. The heavy elements generated after millions of years of combustion previous to the supernova explosion will go on to form new planets and in conjunction with a sun will create a new solar system, probably similar but not quite like our own, which is kind of special. Anyway, the materials from which all human beings are made originally came from a nebula similar to the one shown here. The force of gravity turns hot gases containing heavy elements into planets with reliable elliptical orbits around the Sun. This is how the predictable order known as Newton's universe, a mechanical billiard balls universe, came to be. Spectroscopic analysis of light reaching our telescopes reveals that all the known elements have the same physical properties all over the universe. In addition to hydrogen and helium, the rest, called heavy elements, are decisive in generating the diversity of materials necessary to create and sustain life, such as highly complex molecules. So, it is accurate to say that one or several supernovas had to die in order to create the heavy elements that combine into precise ways to give us life. What all this means is that man's appearance on Earth started more than 10 billion years ago in the confines of space in the beginning of creation. Thanks to the Hubble telescope orbiting the Earth and the images of the random deep fields it has transmitted back to us, astrophysicists estimate the existence of at least 125 billion galaxies in the universe. This figure is about 20 times more than the amount of human beings living on Earth, but still more interesting than this number is the usual shapes that galaxies display. Let's see. 2 laws of nature, inertia and gravity, working as opposing and complementary forces at the same time, combine to create a spontaneous, unexpected, and surprising order. This same order is repeated over and over, not only in the heavens, but all around us, almost everywhere we look. For instance, consider our solar system. It is a vortex that became stable with time. Vortices are plentiful in nature. I must insist that this phenomenon repeats itself all over the place. Let's look at some other examples. The force of gravity is being studied as a possible vortex of space and time. The atmosphere in Jupiter shows a myriad of huge vortices. Hurricanes follow this same pattern. Tornadoes, the same thing. We see vortices in the sea and land, in the desert, in the clouds, in the waves of the sea, in the water going down the shower drain, and in the wake of aeroplanes. This turns out to be the most common shape in the universe. The lines we see describe an exponential spiral. Such spirals can be found in the seeds of sunflowers, in the curvature of animal tusks, and in the distribution of stars in a galaxy, to cite a few other examples. Why is this shape so plentiful in nature? Is this a mere chance occurrence? Not if we are familiar with a cybernetic concept adopted early on from mathematics called recursiveness, which means a repetitive procedure. A few laws regulate all there is, all of creation. Recursiveness allows a few laws to account for all observable complexity. John Briggs and David Peat are experts in chaos theory. They authored the book called 7 Life Lessons of Chaos, published in 1999. They state quite emphatically that self-organization is everywhere. They write, "The list of ways in which nature applies the principles of self-organization is virtually unlimited." William Poundstone, author of the book The Recursive Universe, has his own explanation. The structure and complexity of our world is inherent to the physical laws and do not belong to a special or unknown microstate. The universe is a recursively defined geometrical object. Von Neumann's automatas have relevance not only for biology, but also for cosmology. Creation can be simple. Spontaneous order is created by opposing forces. It allows the universe to solve complex equations without anybody's help. We can view the universe as a quantum computer and the computer program at the same time. In a way, it is similar to DNA that uses its own structure as a construction map to create more DNA, just as von Neumann predicted long before the actual 3D structure of DNA became known. Energy makes physical systems do things. Information tells them what to do, says Seth Lloyd, who is working on building a quantum computer. But wait, we still have two more important constellations of vortices to identify: men and women. Every human being is a living vortex. In fact, every human being is an enormous collection of interrelated vortices that produce and sustain life. Humans are also capable of establishing connections with other persons to create other vortices, such as a family that has its own dynamic of inputs and outputs. We should not be surprised when we realize that many cities have this same characteristic. Paris, London, New York, Boston, New Orleans were created next to a river in order to take advantage of the availability of fresh water and the easy in and out transportation of people and goods. The question we should be asking now is, how do vortices emerge from turbulence? In part 2 of this video, we shall see how chaos, complexity, and life are connected to each other. Part 2 is called The Miracle of Life, and you need cybernetics to understand it.